Hey guys, welcome back. We are going to do a second lesson. It's going to be on regression. So how do we recognize what type of regression equation can be used to model data? All right, so we've already done linear regression many times. Today we're going to kind of combine linear regression with other types of regression. So that's going to be awesome. We're going to do exponential and quadratic regression. So you need, first off, a charged calculator. That's going to be of the utmost importance. So please have a charged calculator. Pause that video, go get your calculator, make sure it's charged, get out your notes, and let's get into this. All right, first thing I want you to do, the following data is the number of species of mammals on the International Union for Conservation of Nature's Red List of Endangered Species from 2004 to 2012 using a linear regression model. It's always nice when they tell us what regression model to use. So if you don't know how to do linear regression model, I do have a video on that. So you can always pause this, go to the other video on linear regression, but you're gonna hit stat edit. You're gonna enter this into your L1 and these into your L2. And you are going to do stat calc number 4. You're going to find the equation of the line of best fit. Pause the video. Go ahead and find that information. All right, so you're going to get an equation of y equals 15.791979995x. You're like, oh my goodness, do I have to write all of those? And here's the answer. Yes, if it doesn't tell you how to round, you write everything you see. So it's going to be minus 31,305.09273. Again, that is stat edit. Enter this data. And then stat calc number 4. That's going to give you your Lin regression model. And then using your equation, how many species are going to be in danger in 2016. So we're going to plug in 2016 for our x value. And we are going to get approximately 531 species if we just substitute this x value in for that. You can plug that right in your calculator and you can see that, which is a reasonable estimation since it seems to be going up by that much. So 531 is reasonable. All right, the data from the scatter plot can be a shape that indicates what type of equation should be used. Now, if the data looks like it's a line, it has a exponent of 1, we are going to use linear regression. If it's kind of has a parabola shape, we are going to use a quadratic regression. And if the scatter plot looks like it's growing or even decaying, we are going to use exponential regression. So once you view the scatter plot of a graph, you can determine what model best approximates the data. If a set looks like an exponential growth or decay, use exponential, such as this one. This is clearly not linear, and it's not rising back up for a U shape. This is decaying. So I would use exponential decay model to get that. All right, and we're going to show you right now how to do that on your calculator. So here we go. Welcome to your calculator corner. Remember, in order to create a scatter plot, now this is important. Obviously, stat edit, you have all your data entered into your lists. If you want to see the scatter plot, not always necessary, but often helpful, you can go to stat plot, y equals, number 1, enter. You turn those scatter plots on, and then you do stat edit, get those, obviously, the data into the list, otherwise you're not going to see anything. And then hit zoom 9, which is zoom stat, and you'll see your scatter plot wherever it is in your table. All right, if you want linear regression, it's stat calc 4. We're going to make your life really easy. If you need quadratic regression, it's stat calc 5, and exponential regression, stat calc 0. So I think the best way to teach this is just to literally do some examples with you. So the first thing I want you to do is enter that data that you see below into L1 and L2. This is the population of a single-celled organism grown in a petri dish over a period of 16 hours. The number of organisms at a given time recorded in a table. It looks like the number of organisms is growing. Enter this into L1. this into L2. Pause that video, go ahead and do that, and then we are going to get the regression model together. All right, now this says exponential regression. So there's really no need to look at the scatter plot. If you didn't know it was going to be exponential, I would go through this process right here. I would see that it curves up or curves down. In this case, we are growing. So there should be some growth. And it should just kind of be the scatter plot that kind of just gets higher and higher. So you can see that it's going to bend up. But we're going to get exponential regression. So you're going to hit stat calc 0. Stat calc 0. And it's going to put it in this form for you, a b to the x. It's going to give you the values of a and b. And all we're going to do is we're going to replace those. So we're going to get y equals 27.203 times 1.51. Raise that to the x, and that's our exponential model for this. Now, this one was nice. It did tell us how to round to the nearest 10,000th. So that is that. Actually, we might have needed one more decimal point, unless they didn't need it. But this is 1 point. I think I'm missing a 1 here, actually. Let me just squeeze that in here. I think this is rounded to the thousandth, but 10,000th. Get one more decimal if you need to. All right, letter B. We are going to use this equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. So you're going to take 18, you're going to substitute that in for x. So it's going to look like this. If you substitute that in, y equals 27.203 times 1.151 to the 18th. Let's just get rid of this 10 here. How about that? To the nearest thousandth, 10th, 100th, 1,000th. All right, good. So we're going to raise that to the 18th exponent, and we are going to plug that into our calculator, and we get approximately 342 if we round up. So approximately 342, and that is organisms. So about 342 organisms. And you could word that nicer and kind of write a whole statement out for that. But that's basically the answer there. All right, good. Let's turn the page. Let's try number 2. About a year ago, Joey watched an online video of a band and noticed that it had been viewed only 843 times. 1 month later, Joey noticed that it had 1,708 views. Joey made the table below to keep track of the cumulative number of views the video was getting online. The problem is he forgot to record after the second month, so we're missing a piece of data there. But let's go here. Write a regression equation that best models these data. All right, so here's what you're going to do. You are going to plug these into your L1, L2, L1, L2. The problem is you don't have this one, so leave this out. Leave out. Do not put 2 with a blank there. You're going to end up with an error. So just when you put your data in, skip this for now and plug the rest of them in. All right. Now, if you can't tell just by looking at the outputs, 8, 1,000, 7,000, 14,000, 29, 62, it's growing by more and more each time. This is going to be exponential. If you do not know that, go to these directions. You can pause the video, stat plot, make sure you turn your plots on and hit zoom 9. That will show you a picture of the scatter plot. And you're going to see that this is an exponential model. So we are going to use an exponential model. So we're going to do stat calc 0. So we are going to get it in this form. It's going to tell you A, and we want to round to the nearest 100th. So that's 100th, 2 decimal places. So A is going to be 836.47. and B is going to be 2.05. So if I plug these in, I'm going to get y equals 836.47 times 2.05 to the x. This is your initial number of views. This is your common ratio, or your growth factor there. So that is there. All right, again, if you're lost, pause the video, slow down, put this stat edit L1, L2, hit stat calc 0, and hit enter a bunch of times. You're going to get these values. You can plug them in that way. Okay? As shown in the table, he forgot to record the number of views at the second month. Use the equation to estimate the number of views. We say estimate because we don't know if it's exactly going to be that, but we know that if our data is accurate, then the model is going to be very good, that our prediction's also going to be very good. So we are going to plug in x equals what? We need x equals 2. That is right. For the second month, we are going to plug it in here. So y equals 836.47 times 2.05 squared. And plug that in. And we're going to get approximately 3,515 views. Which makes sense because 3,515 is somewhere in between 1,000 and 7,000. So it's definitely reliable, and that's a good, accurate guess based on real data. All right, last one here, number 3. Last one. Biologists conducted a study of the nesting behavior of a type of bird called the flycatcher. They examined a large number of nests and recorded the latitude for the location of the nest and the number of chicks. The latitude and the number of chicks. So this model looks like it's going up, hitting the max, and coming back down. We would say that a quadratic model is most accurate. It appears to be a parabola. It increases and then it decreases. One model that can be used is given. Now look, I know it's quadratic because it's x squared. So let's use this, plug this into your y equals, and let's fill in our chart for the mean number of chicks. And if we do that, we're going to get 4.675, 5.375, 5.675, 5.575, 5.075. It's going up, 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 and down, down, which is how parabolas behave. All right, based on this quadratic model, what's the best latitude for hatching the most flycatcher chicks? All right, we can look at the graph. We can look here and approximate. It's somewhere just past 50. So it's going to be somewhere about 52 degrees of latitude, but we don't know exactly. But we are going to go to our table of values. So I want you to plug this in, go back to your table of values, and what you'll see is that it is somewhere, probably, if you look at 51, 52, 53, 54 as your x's. You're going to see 5.683. It gets a little higher, 5.687, 5.687, 5.683. Now, if you don't see these, you might have to adjust your table settings so that you're seeing decimals. So it appears as if the turning point is somewhere in here. So we're going to say, because it gets higher, higher, same, low, and then lower. So we're going to say somewhere between 52 degrees and 53 degrees of latitude. All right. Models can be used to answer questions about how two variables are related. We have 3 models: linear, exponential, and lastly, quadratic. So these two lessons basically wrap up the three most common functions you guys know. Linear, quadratic, and exponential. They all come together in this awesome lesson of regression, making predictions, using calculator to get the best model. Really cool stuff. Lot of real world application. Just tons and tons of good stuff here. So again, if you didn't quite get all the calculator work, go ahead and play around with it. Shoot us a comment below or even email us, and we'll help you adjust your table settings so that you can exactly get all these numbers and see what we did. All right, keep working hard, work on your practice, work on castle learning, and remember, we miss you, and we can't wait to see you guys. Thanks. Bye.